Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on basic calculator. So let's just quickly jump into the problem statement, understand it and start solving. Okay, last time we solved the word ladder. I'll mark it check. You can find it in the list. Let's start with basic calculator. Okay, given a string s representing a valid expression, implement a basic calculator to evaluate it and return the result of the evaluation. Note, you are not allowed to use any built-in functions which evaluates the strings as mathematical expressions such as eval. Okay, so we could be given a string like this, 1 plus 1, we have to return 2. Similarly, 2 minus 1 plus 2, 3. And similarly, we can have a complicated expression like this, which is inside the brackets, and we have to return 23. Okay. Now, the problem statement is very simple. The solution might be little tricky, but not that hard. Okay. With this, we can jump into the problems in solving the problem. But before that, please think of an approach that you take to solve this. You are ready? Okay. Well, one thing is that we could, if it was a simpler expression, it was much easier to solve, right? After each integer we'll get a plus or minus sign, and we'll add them or subtract, and we'll be at the end of the solution. But it can get complicated when we have the opening and closing brackets, right? So it would make more sense. Let's say we have this 4 plus 5 plus 2. This is one solution that is supposed to come out of this bracket, and then we have to add it to the rest of the solutions. So we have to solve the bracket solutions inside the brackets only. So for this, we can use stacks. Okay, because when we have stacks, you can directly send your whenever you get the opening bracket, you can send it to the stack, you can send the result to the stack. Whenever you get the closing bracket, you can pop it back from the stack, add it to the rest of your result, right? One more key thing to notice here is we can have signs. So it's not all positive, we can have negative numbers as well, right? And negative numbers, when we are adding to the positive ones, we have to solve that complicated equations, right? So we need something to keep track of the signs as well. So with this, let's start with the solution and let's see. Okay, and one thing, firstly I'm going to take you through the solution that you should be using, because if we go to the Grind 75 list again, and if I showcase the topics, it comes from the stack. Right now, it might not be the most efficient solution using the stacks, but it would be a good question to learn about the stacks, right? Later on, of course, I'll go with the more better approach as well, just to solve the solution, just to solve the problem. But I would say that please focus on the stack solution, because that way you will have more clarity on solving this question using stacks, so that you'll have better understanding for future problems as well. Okay, so let's start. First, let's initialize result equal to 0. Then what else do we need? We need one variables for sign, so we'll keep it in int sign. We'll initialize 1 for positive sign. Okay, apart from that, we'll keep another variable for storing storing the current number. Okay, or the at each level when we are getting a number, so we can say current number is equal to 0. Okay, we need a stack of type integer. Stack is equal to new stack. Okay, let's start with our iteration. For int I is equal to 0, I is less than s dot length length I plus plus. Okay, now one by one we'll check whether we have a plus sign, minus sign, opening bracket or closing bracket, right? And based upon those conditions, we'll form our solution. So first we'll construct our first number that we are getting. So we can say current number, and umber is equal to it is going to come from characters, so we cannot come to current number directly. We have to find our first character. Current character is equal to s dot caret I. Okay, we got our first character. Now if we'll check, so it can either be signs or brackets. It can either be opening closing bracket plus minus sign, or it can be a digit directly. So we'll directly check if it is a digit. So characters that is digit, and we'll pass the first character, current character. Okay, if it is true, we'll construct our we'll construct our current number. So we can say current number is equal to current char minus character 0, so that we get our number. Okay, since it's the ASCII formation conversion, or we'll say construct the current number. Okay, now we found our current number, so let this be like this. Okay, if it is a digit, we will have our current number. If it is not a digit, so we'll check else if current character is equal to either the plus sign, we'll have the plus sign, or current character is equal to minus. Now if we have a plus sign or minus sign, it does not change much for us, because we can always do the addition. Plus of plus would be plus and plus of minus would be minus. Now based upon the sign, we'll perform our calculation. So we can say add the current number that we have to the result with the current sign. As of by default, we have kept the sign as positive, so you can say result will be sign, that is if it is positive, 1 multiplied by our current number. Okay, now what else do we need to do? Once we have done this, once we have found a result, so it will be sign, that is 1, it was already positive, multiplied by current number, that was 1 into 1, that will go to result was earlier 0, it will become 1. So we will reset our current number as well. So you can say reset current number. Okay, so we'll say current number is equal to 0. Okay, and we'll change the sign as well, because we don't know, we know that for positive or negative we are doing the same operation, but we don't know whether it was positive or negative, so we have to update our sign as well. So we can say sign is equal to current char if it was equal to plus. Okay, if it is not not plus, so if it is plus, we'll keep the sign as 1. If not, that means it's minus, we'll keep the sign as -1. Okay, else if, so if it was a digit, we have written the condition. If it's a plus minus sign, we have written the condition. We need the condition for the brackets. So if current char is equal to opening bracket, we don't need the closing here, opening bracket. If we find a opening bracket, we need to push our current result. So let's say we were calculating this part 1, and then we encountered opening bracket, we'll push our current result to the stack, so that when this one is calculated, we'll bring this result out and add it with the 1. Okay, so we will say push the current what's happening, result and sign to the stack. Okay, so we can say stack dot push result. Why do we also need to push our sign? Because if the internal number was negative, at the end we should be able to reflect negative again. So we'll push this one inside the bracket calculation also on the stack. So push sign. That's why we took sign in integer format, so that we can use only single stack rather than going with two stacks, one for the signs, one for the numbers. Once this is done, for now we will reset a result again, because internal result will be calculated separately, then it will be added to the outside result. So we'll say reset result, and we'll also reset a sign as well, and sign. So we can say result is equal to 0 and sign is equal to 1, right? Now else if, so we covered digit, we covered positive, negative, we covered opening bracket, we have to check for closing bracket. If current char is equal to closing bracket. So what will we do in case it's a closing bracket? First let's calculate the result that we have. Okay, so we can say add the current number to the result with the current sign. Okay, so we can say result will use the same equation, plus equal to sign multiplied by sign multiplied by current number. Once we have this, we'll reset our current number, reset current number, so we can say current number is equal to 0. Now we'll pop the sign and the previous result, so the internal result, from the stack and add it to the result. So we can say pop the sign and or we should call internal, we can call it previous actually, previous result from the stack. Okay, so we'll say result. Now first we inserted the result and then we inserted the sign. So when we are doing a pop operation, we'll get the sign first, so we need to change the sign first. So we'll say multiplied by, okay, stack dot pop. Okay, this is for previous sign. After that, result plus equal to stack dot pop. This will be our previous result. That's it, right? We covered all the conditions. When we are first we form our current number, we check if it's a digit or not, we form our current number, we check for the plus sign if it is the next one. So once we found our current number was formed. Next time we got a sign, so we added the current number to the result. For a complicated situation like this, we added the current result, we got the opening bracket, we push the result to the inside the stack. Then we again encounter one more opening bracket, we again insert the result to the stack, we solve the internal stack first, then we come out of it and then we add it to the outer results. That would be 1 minus 3. Okay, with this in the end we can return our results. So where is our loop ending? For loop ends here, so we can say the last number that will be left. Okay, so we have to calculate for the last number as well. So we say add the last number to the result, of course with the sign. So we can say result plus equal to sign into current number, and then in the end return result. That's it, right? So I know the question is from the hard category, but the solution is not that complicated once you break it down into smaller chunks, that we only have to figure out how do we solve the conditions for the signs. Okay, let's run it once. And yes, the overall time complexity will be O of n. Okay, we have compilation issue somewhere. current. Current. Okay, let's see. Okay, let's submit. Excuse me, wrong answer. 33 of 44 cases didn't pass. Why? Something is expected was 2147 and output was 4. Okay, a direct string was given and we could not calculate for that one. This can be tricky. We need to incorporate this. Let's see what could we have we done. So we have the result to 0, we have our sign, we have our current number to 0, we have initialized the stack for the calculation is equal to 0. We started with our iteration, we found our current character. Let's say first character, or for each iteration that would be current character only. So let's remove first character. Okay, now once we have the current character, we check if the character is digit, we pass our current character, we form our current number, that would be current number. We didn't form our current number, current character minus 0. Okay, I got it. We need to change current number multiply by 10 and then plus. Okay, let's run it now. Okay, while running it was working, for summation it wasn't working, right? Let's submit again. Let's see, current character plus current minus. Okay, so it's working fine, but as you can see, it beats 26.93% of the solution. It's still on the higher line of this graph, but still the performance is not that good. But again, I would always suggest that you use this approach to solve the basic calculator, so that it is understandable how we are working with stacks, and how you can use the stacks for future use cases as well. But apart from that, we can have a more efficient solution if you look at the problem statement like this. Let's say you want to solve this problem, okay, and of course using stacks we are taking more time, and we want to improve our overall efficiency. Of course both the solution would be in O of n time complexity, but again we can improve it further. We call this function to solve our answer, right? And when we encounter a bracket, we recursively call the same solution again with the internal string members to be calculated, such that we will use recursion to solve the same problem. Okay, let's quickly take a look at that. Okay, but again I'm suggesting that please use this approach to solve the solution. I know in overall time complexity is O of n only, just in performance it lags a little from the rest of the solution. So I found one really great solution to solve this problem. What we can do is, we have to call our solution recursively, so that for each internal calculation of result that we were using stacks for, now we'll use recursion. So we'll say we have to calculate string, right? So we'll call another function, return calculate helper. Let's call it calculate helper. We'll pass the string. Oops, why am I typing it? Okay, say function to be called recursively. Okay, so you can say private int calculate helper. We are receiving the string s. Now when we are calling it on the recursive levels, we may lose track of how we are iterating through the string. So that's why we'll keep a global variable to track our strings. So we can say int index, that will be traverse the traverse the string in one pass. Okay, now we'll start with our calculation. Now again the solution is going to look very similar. The only things that are going to change, the fundamentals wouldn't change. The only thing that is going to change is we are going to use recursion to solve it. So let's have our variables result, int result is equal to 0, int current number is equal to 0, and int sign is equal to 1 for positive, right? Again, while now we'll start index is less than s dot length. Okay. What can we do? First we'll get the first character. Current character is equal to s dot caret index, right? Now if now we are going to check for the same. Current character is greater than equal to 0. Okay, and current character, this is same as doing the check for whether it's a digit or not. Like we used in the previous solution, you can simply check it with the if it's is digit or not. Okay, so if it is greater than 0 or less than 9, then it's a digit, right? If this happens, we can say current number, will form it in the same fashion, will be current number multiplied by 10 plus current char minus 0. Okay, so we got our current number as well. See, the solution looks exactly the same as we were solving previously, and now the recursive parts will change. Else if C URRENT current character is equal to opening bracket, we don't need the closing bracket. If it is equal to opening bracket, we are going to say current number is equal to, we'll call the function again recursively, calculate helper, we should have named it calculator, calculate helper, and we'll pass our string. Okay, this will be to solve internal result. Okay, else if current character is equal to closing bracket. Now if you pay attention, this is the same where we are using recursion. Earlier we were passing them to the stack to solve the internal problem first. Now we are using recursion to solve the internal problem first. Okay, else if it's a closing bracket, then we can simply return the result, right? So we can say return result plus sign multiplied by current number. Okay, now else if current character is equal to, we are still left with our positive and negative, right? Is equal to plus, or current character is equal to negative. In this case, what will we do? We'll change the result, we'll change the we'll change the result, we'll what's the word, revisit, no, reinitialize, reset a current number. Okay, so we can say result plus equal to sign multiplied by current number, as we did in last case as well, and we'll initialize current number is equal to 0. Okay, and again we'll change the sign as well, sign is equal to current character CHARACTER is equal to, we check, minus, or we can check plus, same thing we did last time. If it is true, it will be 1, otherwise minus 1. Okay, let's put them in bracket. Okay, so we don't need this. Okay, so if it is positive sign will change to 1, negative sign will change to -1. And in the end, when the while loop is over, we can, what do we need to do? Once the complete loop is over, we can return our result. So we'll say return result again plus the last number that is still left. So sign multiplied by current number. Okay, since last number is left to be processed. Okay, now so we have our index. Okay, we are going through current character as dot caret index, and okay, let's run it. Oh, what's wrong? Expected something is wrong. Oh, oops. Yeah, let's run it again. Cannot find symbol s dot length. Cannot find symbol s dot length. That is because it's a method, not an array. It's from the string. Okay. Okay, something is wrong again. Current character, currentcharacter. Current character, that is correct actually. What is wrong? Current character looks correct. currentcharacter. Oh, current char. We have named it current char. Okay, let's run this time. Let's see. It's taking some time. Time limit exceeded. Oh, okay. We are not changing the index, so it's running in infinite loop. Index plus plus. Right? Once we have processed the index, we have to move the index as well. Let's run. Okay, something is not correct. Stack overflow. Still. Current number, we are calculating, calling it again. Current number, we have passed a string. Somewhere something is missing. I think, where is our index? We have our index. Oh, okay, we should initialize the index as well. So you can say index is equal to 0. Let's run now and check. Again, stack overflow. Okay, somewhere let's remove the index. Where are we using our index? Index, we call it plus plus. Let's run. What? Okay. So we have the if loop, the else loop, the else loop, the else loop. We have processed everything. We're moving the index. Okay, let's submit. Okay, beats 96.78. But again, as I mentioned, again this has the same time complexity. Yes, it is little more efficient. It is more efficient than the previous solution, but I would suggest everyone to first go for the stack approach so that you have a better grasp on the stacks as well. Okay, and this is the final solution with the improved approach. Okay, that's all from today's video, everyone. For anything, please let me know in the comment section. If you like the video, please share it with your friends who are preparing for the interviews. In the end, please like, share and subscribe. Thank you.